Today on the hookup, we're going to learn about individually addressable RGB LEDs and how to control them with a microcontroller like the ESP8266 based Node MCU. RGB LEDs are super cool and fun and flashy and sometimes a bit tacky, but they can actually be really useful too. In this video, I'm going to cover the basics of writing programs for individually addressable RGB LEDs by programming a simple timer for my high school classroom. The goal for this timer will be to count down from any custom time and gradually change color from green to yellow to red as the timer gets closer to 0. I'll use this timer in my classroom to keep track of how much time is left in the period, but the concepts that I'm going to talk about are applicable to any individually addressable RGB project. RGB LED strips come in hundreds of shapes, sizes, and configurations, but they can be broken into two major categories. There's 3-channel RGB strips and individually addressable RGB strips. A 3-channel strip has 3 different ground circuits and 1 common voltage. Each different ground circuit controls a different color of light, red, green, or blue. By changing the resistance on those channels, you can change the brightness of each channel, which allows you to produce a huge range of resulting colors. The major downside to these strips is that you can't pick and choose which LEDs are lit. The entire strip must be on or off, and every LED will be the same color, so you can't do any of the really cool effects with them. By contrast, individually addressable LEDs have a tiny microcontroller in each of the LEDs that allows each one to light up with a unique color and brightness. The strips have a positive voltage, a ground, and a data wire. Each time the data reaches an LED, it's read and passed down the strip to the next LED. The first chip reads the incoming message address as LED 0 and then performs the instructions for LED 0. It also passes the data on to the next chip after increasing the counter value by 1. In other words, the first LED says, okay, I'm LED 0. The next guy who gets this message is LED 1. And this message continues down the strip until there's no more LEDs left. The important thing for you to know here is that each LED in the strip needs to be given specific instructions with that specific address in order to turn on. Individually addressable RGB LED strips come in 5 volts and 12 volts, and each strip has some unique advantages. The 12-volt strips are less susceptible to voltage drop and are therefore able to travel longer distances before the LEDs become dim and the colors become inaccurate. If you're planning on running your strips any significant distance, you'll probably want to inject power on each end of the strip at the very least, and probably somewhere in the middle as well if you're using the 5-volt variety. The upside to using a 5-volt strip is that you'll be able to power the whole thing from the same power source, so you won't need a buck converter or some other voltage regulator for your Node MCU. For our project today, I'm going to be using a 5-volt WS2812B LED strip because I'm not worried about voltage drop since my project is only going to have around 60 LEDs. 57 to be exact. In the Arduino IDE, we're going to use a very popular library for controlling these LEDs called Fast LED. To get started with your project, you need to set up your LED strip in the sketch. To do this, you'll need to do 3 different things. First, you'll need to define how many LEDs you're going to have in your strip. This refers to the number of individually controllable nodes. So if you bought one of those LED strips that only has 1 controller for every 3 LEDs, you'll need to divide the total number of LEDs on your strip by 3. For our WS2812B LEDs, each LED can be controlled individually. So my 57 LEDs needs to be declared as 57 controllable nodes. Second, you'll need to declare your LED matrix. To do this, you'll type CRGB and then give a name to your LED strip, and then tell it how many LEDs are in that array using the variable that you defined in step 1. Third, you'll need to set up your LED strip in the void setup by using the Fast LED add LEDs function. You'll tell it the type of LED strip you're using, the data pin it's connected to, the order in which the red, green, and blue LEDs are addressed, the name of the LED matrix, and the number of LEDs it has. That's a lot of information. Once you have your LED strip set up, you can tell a specific LED to turn on at a specific color by calling the name of the LED strip and then the LED number that you want to light in the square brackets, and then equals, and then the color you want. When selecting a color, you have a few different options. The first one is Classic RGB. In this configuration, you can turn on each of the red, green, and blue channels to 255 levels of brightness. Using this method, you can generate around 16.8 million unique colors, but the downside is that you need to manipulate 3 variables in order to change the color. Another option that allows us to manipulate the color while only changing 1 variable is called HSV, or hue, saturation, and value. Hue refers to the base color. 0 is red, and then all the other colors in the spectrum are represented as you go all the way back up to red again at 255. Saturation refers to the vibrance of the color. If you choose a saturation of 0, there won't be any color, just white light. And 255 would be the richest or most saturated color. The last value, which is value, is essentially just the brightness of the LEDs. If it's your first time working with these strips, I highly recommend that you compile and upload your project after making a single LED light up as a custom color. I know that the first time I got my strip working, I was beyond excited, and it really helped me push through some of the issues that I ran into later on in the project. For my specific project, I'm making a timer that transitions from green to yellow to red. So you can see that I need to go from a hue value of about 96 down to a value of 0. And I can keep my saturation and value numbers constant. And that's nice because it means I only need to work with a single variable. The trigger for my timer is going to be an MQTT message. I always use the same code to receive my MQTT values, and you can see that after receiving a new payload, it converts the payload into both a string and an int in separate variables so that I can decide which data type I want to use for my specific function. I use Home Assistant and Node-RED for my home automation, so I already had an easy way to send an MQTT message. But if you don't already have an MQTT server set up, you could easily just use io.adafruit.com, which offers a really nice web interface and it has IFT integration without the need to run a separate Raspberry Pi at home. Once a new MQTT message comes in, my code is going to do a few things. The first thing we'll need to do is reset our LEDs remaining to the total number of LEDs in the string. That's going to result in the bar filling all the way back up. Then we need to calculate how often an LED needs to disappear. This calculation is pretty simple. We just need to take the total number of minutes for the timer and then divide it by the total number of LEDs in the strip, which will give us the fraction of a minute that each LED represents. Since the Simple Timer library in Arduino wants an input of milliseconds, we'll also need to multiply this by 60,000 in order to convert the minutes to milliseconds. We'll then use this number of seconds to tell our program how often it should subtract an LED from the LED's remaining variable. In the simplest situation, if we had 60 LEDs total in our strip and we set our timer for 1 minute, each LED would only last for 1 second. To actually light up our LEDs, we could type in each LED's specific address in the matrix and tell it which color to turn. But that would take forever, and it's way more work than we need to do. Instead of doing that, we're going to light them up using a for loop. Basically, in a for loop, you declare some variable, I in this case, and then you give it a condition that has to be true for the loop to continue. Which means this loop will continue as long as the variable I is less than my LED's remaining variable. And then last, you need to tell it what to do every time the loop completes. In this specific loop, I have I++, which just means to add a value of 1 to the previous value of I every time the loop finishes. You can see that each time the loop runs, it will turn on a different LED based on the value of that variable I. If the LED's remaining variable is equal to 25, the for loop will run 25 times and turn on LEDs 0 through 24. If my LED's remaining variable is equal to 8, it will run 8 times and turn on LEDs 0 through 7. The last piece of the puzzle is color changing. As I mentioned before, I'm going to manipulate the hue value of my HSV color. When the timer is full, I want it to be at a value of around 96, and when it's empty, I want it to be at a value of 0. But since I only have 57 LEDs, I can't use my LED's remaining variable because that would only go up to 57. Instead, I'm going to use the map function for Arduino. This compares two number ranges and results in the equivalent position on a number line for those two ranges. I'll be changing my value from 0 to 57 to a range of 0 to 96 in order to adjust for my color. There's a few other little lines of code in here to allow me to cancel a previous timer before inputting a new one, but overall the code should be pretty easy for you to comb through and figure out what's going on and modify it as needed. Here's what the timer looks like in action. We can set the timer to 1 minute, and then as the LEDs start to disappear, we could send a different timer for say 5 minutes and overwrite the previous one. And since no IoT project would be complete without voice control, I can also say, "Alexa, set my classroom time to 10, and it will start a 10-minute timer for us. I hope this video will be helpful for you in making your own RGB LED projects. If you'd like to build this exact same project, I put the links down in the description for the specific products that I used. I'd also like to hear in the comments if you prefer videos where I just build a project and then I leave the code in the description, or if you'd rather see videos like this one where I explain how the code actually works. As we get closer to Halloween and Christmas, I'm going to be making some more videos about my house LED projects. Ben from Bruh Automation made a really good video about RGB LEDs that focuses on using pre-made animations. So I'm going to look at different things like using separate LED arrays for different parts of the house and custom tailoring your LED arrays for the specific features of your house so that you can have animations that are custom to your house only. Thank you again to my awesome patrons from Patreon for your continued support of my channel and my projects. I only have these video ideas planned out around 2 weeks in advance, so if you have an idea for a unique video that you'd love to see me make, let me know down in the comments, and if it sounds exciting and it hasn't already been done well on YouTube, there's a good chance that I'll make it. If you'd like to support my channel, check out the links in the description. If you enjoyed this video and you'd like to see more like it, please consider subscribing. And as always, thanks for watching The Hookup.